I'm just going to run through a few of the little MCMC computer demos I've done. I've got the lecture notes open here, and I've searched for computer demo in it, so we can go through and look at each of them. First one is TPM, stands for Transition Probability Matrix. Here in the MCMC demos folder, if you've installed it and done all the things it suggests on the GitHub README, then you just say TPM. It starts there. That's the info window. If you press the 1 key, you get the first screen. Woo! And if you hit the space bar, it starts and stops the process. So in all of these, hitting the space bar basically will suspend the process or start it back up again. Now, some of the other things you might want to do are hit the O button. Lowercase o moves things one step at a time. Sometimes you hit it and it doesn't move. And then that's just because it stayed in the same place, and you keep moving it along. There you go. If you want to hit the 2 button, you get that view, which shows a trace up above the bouncing blob. In all of these simulations, if you hit the E button, it resets the running averages, including the trace plots, and keeps running from the current state. If you hit S, it just restarts the MCMC or Monte Carlo simulation from an independently drawn value. The only other screen left here is 3, which is that. If we hit E to reset the averages, you get that. If you hit S, it starts it anew and resets the averages, and you see that it falls back into line. That's pretty much all there is for TPM. When you're done with it, Command Q quits it. All right, let's see what's next. Beta sim. All right, not too much going on there. It's just beta sim. Once again, you hit the 1 button, and that's going to show you the MCMC sampler. It always seems to start from the corner. That's just where I initialized it to show that long period of convergence. And it's moving around. Once again, you can stop it, and once you're there, you can move it in little one by hitting the O key. You get that. If you hit 2, you get the comparison with, on the bottom, you have posterior estimated from independent Monte Carlo, and on the top, you've got MCMC. So one thing I'll note is that on any of these screens, if you click on it so that it's the active screen and hit the backslash button, it turns it into full screen. Hit the backslash button again, whoop, and it goes back to where it was before. That gets quite useful for some things. We can go up here and look at that one. Okay, well, that's about all there is on that one. Quit out of it. What's next? Aha, this one. There's a lot that goes on in inbred P. So let's just see if we can copy that command. Needs an underscore in it. Great. Start that up. And hit the 1 key, and you see all sorts of different things. And if we hit the space bar, we have to be... Oh, must be fixed P, so it actually doesn't start on jointly. Let's see what's going on there. That's interesting. So anyways, you have to go to the info window, and you would want to hit J. And now it makes the updates by updating both P and F jointly at the same time. And you see it walking around there. You've got a trace of P, a trace of F down here. These things can control the standard deviation of the proposal. So if we wanted to make the F proposal way bigger, we could go up here. Wow! And now it... So clearly, the x-axis here is F, the y-axis is P. We could set that back down to something a little more reasonable. You could also make it super duper small. That doesn't change very much. So if you were inclined to do that sort of thing, you can do that. I think if you hit 2, oh, sorry, take that back. When we're active on that screen, hitting 2 does something else. But if we're on the info screen, hit 2. Okay, so this is gives you a kind of a handy view where it shows what you're doing in each step, and then if you hit 0, you can go through it. And basically, here it proposes a new value. It shows the proposed value in blue. If it accepts it, it turns to green, and then it moves there, and so forth. Bouncing around, doing all that good stuff. Once again, if you wanted to go \, it's going to make it full screen. Let's go back to our one view. Okay, and stop for a moment. Okay, so we come back here. That was showing the joint updates. If you want to do component-wise updates, you go to the info window, which is this one here in the upper left, and hit C. Boink. Now it says it's doing P and F component-wise. Let's clear things out by hitting the E key, and now we see that it moves only in vertical or horizontal directions. And if we come over here, we can see that it proposes a new value for F and so forth. Once again, that was hitting the 2 button. It gets us there. Back hitting the 1 key gets us this. So that was component-wise. The silly method is one where we've added, where we're basically doing component-wise updates, but we've also added these U's, but we're not using them for any particular reason. So capital S gets you the silly method. Hit the 1 key. Here we are, and now we see that these indivs, the U vector is being updated as well. And get a closer look at that way. All right, so it's doing that, and if we look at what happens, simulate a new value for the Z's. Okay, so I guess in the program I call them the Z's, in the lecture I call them the U's, and they're invariant to transformations of notation. Cool. And then finally, we can get down to the Gibbs sampler. To invoke that, you just go to the info window, and you hit G. Boom. And now you see it buzzing around there. So one of the things that I try to do is, let's go back to, say, component-wise sampling, I think is where we do that. Reset the averages and let it go. So now it's doing component-wise sampling. And it takes a little while. I guess if you hit X to blow all the windows away, it gets through a lot more iterations quickly. Then you can hit 1 again, and there they are. One thing that you can do is, if you come to the info window and you hit F, then it fixes all the variables. The only other one is P, except F, and it basically just samples the F distribution, as you can see there, or in the F dimension. And when you're doing that, you might want to, oops.
What are you doing, Steve?
I'm just recording something for Matthew Robinson, who's going to be using all of these.
I'm going to have to go somewhere else and talk to yourself.
Okay.
Let's see if we can show it
So another 5 minutes or so. Anyways, you see that the distribution that comes out here is actually an approximation to the full conditional distribution for F, given the current value of P. If you hit F again, then it starts sampling F, and if you hit P, it does the same thing, where F is fixed and P can be sampled. All right, so that's kind of a nice way of introducing the idea of a full conditional distribution. I think that's about it for this. Yeah, pretty much. So we're going to quit out of that and go on to the next one. We're going to run new hybrids via run new hybrids. So new hibs. So we should be able to say run new hibes.sh. See what the heck that looks like. New hive dev. Fascinating. Okay, so there's a problem there. I'm gonna have to get you. Oh, I'll have to get that. Okay, well, let's see what else we've got here. Yeah, because those actually aren't. Huh. Well, crazy. And then what about this? Pritch. All right, cuts for new hives. No, we're running on Scottish kitties. Okay, there we go. And that lets you run all your things here. These are the average. This is the current allele frequencies. Some interesting things here. You can make it full size, and if you hit Shift M, it gives you more columns. Shift L gives you a legend. And if you Shift F gives you fewer columns. So that's kind of a useful thing to be able to do sometimes. Let's see if there's any interesting stuff that happens here. Oh, you can put those into columns, but that's not particularly useful. Okay, once again, that was Shift M and Shift F for more and fewer columns, and Shift L for a legend. Great. And once again, that's \key that gets it full screen. All right. And then this one down here says computer demo on page 281. That's not, that's basically just the same as the MC3 demo. MC3 demo. Let's see if this works. Hit the 1 key, that's basically just shows you the distribution. Hit the 2 key, that shows you the distribution with squashed down with a bunch of different exponents. And if you hit the 3, this is the cold chain. So if you hit 3 and then hit the space bar, it starts in from the side and your little particle starts moving around. If you hit S, it'll start it in random places. So you can start it by hitting S and it'll start it from some other random place. And you can see that depending on where you start it, you get stuck in different places along the way. Cool. Okay, so presumably if we hit 4, aha, there we go. That's looking good. So now we're looking at all the chains. The cold chain or the standard chain is on the top and all the others are down on the bottom, but they aren't coupled at the moment. So they're each running in their own world. Once again, you can stop it. You can hit O to do it one step at a time. But now if you hit the lowercase c button, it starts coupling the chains. Let's see what happens when we do that. We'll hit, actually, let's get rid of those averages for now. Now we'll hit C, whoop, and you see that things start jumping from one level to the next, which is pretty cool. And then if you hit C, it stops the coupling and it just moves around again. You hit C, and they're coupled and moving around a little bit better. Hit C, and they're not so much. All right. Well, that is about the extent of it. I don't think there's a whole lot more to say. Anyways, that was just a little primer on some of the things I do with these little OpenGL MCMC demos. Cool.